Thanks, Andres. So I just share my screen. And we'll talk in the next 45 minutes about some myths about SQL performance tuning. And the question is which of these myths are true and which are false. So a lot of people think that performance tuning in databases is just adding more memory, creating additional indexes, perhaps add some hints, change some init-ORA parameters, or if all that doesn't help, then there is still the option to fly in a firefighter or a performance specialist that solves the problems with the performance of the queries or the DML statements that are too slow. Actually, that's not so easy, and I do quite a lot of performance tuning and always see that in some cases the problems cannot be solved with one of these features I just mentioned. They should be solved before, and that's what I always see, that a lot of people have no or just a wrong meaning about performance in Oracle databases. My name is Dani Schnider. I work for Trivadis in Switzerland, in Zurich. I'm an Oracle ACE director. I have a Twitter account and a blog. So all the information you find here on this page. And one part of my job is also giving courses for Trivadis training. I'm one of the trainers of the Oracle SQL Optimizer and Performance Workshop. That's what I mention here, because this 3-day course is about how performance tuning and especially SQL performance tuning works, how the optimizer works, and some of the examples I will show you in these presentations are from this course. So I don't show examples from real projects, so at least most of them. I had other presentations before that you probably have seen, so I will not talk about very complicated SQL statements, but I will use easy examples to just show the principles of performance tuning and how this works in an Oracle database. When I prepared this presentation, so the original version of this presentation was this spring at Apex Connect, which was also a virtual conference. And during the slide preparation, that was in the middle of the lockdown here in Switzerland because of Corona. So we always stayed at home and had a lot of time in the evenings. And what to do when you have a lot of time? You watch all the movies that you have in your library. And for example, we watched all the James Bond movies again. So from the 60s till a few years ago. And that inspired me for this presentation. So the titles of the different chapters are related to some James Bond movies, as you just will see in a few seconds. And also the demos I will show, or at least some of the demos. So I start with Try Another Day, which is about performance tuning. So that's one of the myths, that performance tuning, that's something that can be done after the development. So at the end of a project, before it goes to the production, let's do a few days of performance tuning. But actually, that's not so easy. And when you read the introduction chapter of the performance tuning guide in the Oracle documentation, you see these three areas of performance tuning tasks: performance planning, instance tuning, and SQL tuning. And most of the people only think of instance tuning and SQL tuning. So instance tuning is a typical DBA job. So the DBA has to configure the database, has to look that the IO balancing works right, that the hardware configuration is good, and all these things. SQL tuning, that's what I mainly do. So things like indexing, gathering statistics, partitioning, and so on. But what is also important is performance planning. So the part on the left of this slide, that you have a good data model, system architecture, and all this stuff. One of my first performance reviews when I worked for Trivadis, so that was more than 20 years ago now. I was together with a colleague of mine with a DBA, a few days working on the side of a customer. I did the SQL tuning part, he did the instance tuning part. And at this time, so the first thing, or one of the first things I did did a trace file, a SQL trace, and then with tk-prof, I found out that this statement here, for example, is the slowest statement running in this database. It was running for around 3 minutes, but actually it's not executed once. It was executed 200,000 times, and actually in 3 minutes, that's not too bad. So the performance of this query is actually very good at this time with that hardware that they had. And also the execution plan we see here is a table access by index row ID of a table with a very short name. So I don't know the application in detail, but actually there is nothing that can be improved here with SQL tuning. Perhaps the hardware is too slow, but that was also not a reason. But what makes me curious was, how is it possible that this statement, which was executed so the trace file was a few hours on the development database, how can it be that the statement is executed 200,000 times on a development or a test database? And that brought me to the idea to ask some questions to the customer. For example, can you show me the application or the data model or whatever? What was strange here is all the statements look like this. So none of the SQL statements in the whole database ever did a join. So there were only queries on one table. There were many indexes, so 20 and more indexes per table. So the whole application was over-indexed, I would say it today. And this, by the way, was the data model. So a lot of tables, no foreign key constraints. So so it just looks like a nice picture, but for me it was useless to understand it. And yeah, there were a lot of other things. Finally, I found out what they did. It was an old-fashioned application, originally written on a host system with COBOL, and with embedded SQL, they do all the stuff on the database, and they use the database like a file system. So they did all the logic, so joins like this were implemented in COBOL loops, and for every row that was found with an index access was it reads the row ID and went to this table. So they implemented their own database system with COBOL and used Oracle as a file system. Yeah, what can we do here? In this point of time, nothing. So the best solution would be throw away the whole application and start from scratch. Of course, that was not possible, or at least, yeah, at this time, I would not write it into a review paper and say throw away the application. So we tried to find some, yeah, nice words to tell the customer, this is not a good application, and it's not the idea how a relational database works. That's what I realized there, and in many other projects later on, that performance is not something that can be done at the end of the project, that you do during the tests. You always test with 5 or 10 data rows in a table, and then you're surprised when it doesn't work with 1 million rows or something like that. And that's really important, that you already think about performance when you do the system architecture, when you design the application, when you do the data model, that you decide, okay, is it really useful to work like this, or to always join 20 tables, or to denormalize some data. There are a lot of options available, but you have to know them, and you have to take care and to think about performance not when it's too late, not when the application is already too slow, but at the beginning and in all phases of a project. So that's the first message, and this myth that performance tuning can be done by a specialist at the end of the project is definitely not the best approach. So it's good to keep that in mind. The next part is indexing, from Index with Love. Many people, and I was one of them before I started at Trivadis, many people think that index access is always a good thing and full table scan is something bad. If that would be the case, then I think a full table scan wouldn't be available in Oracle and in all other databases. So there must be a reason that a full table scan can be better than an index scan. Otherwise, we always would use indexes. And to show this, I will show you a few examples and a nice demo afterwards, the longest demo in this presentation, by the way. And also part of these presentations are some surveys. Here it's not so easy in a virtual meeting. I cannot just ask who is for execution plan A or B, but you can answer these questions for yourself and just write it down and then check at the end how many of these survey questions you were right. We have two execution plans here for the same statements. That's, by the way, one of the queries we use in our performance tuning course. And when you compare these execution plans, what do you think, which of the plans is better? Is it option A with a lot of nested loops and index range scans, or is it option B with hash joins and full table scans? In this case, just let you look a little bit, but I already can give the first answer, which is always the right answer. The answer is, it depends. And in this case, and in many other cases, it depends on the number of rows, or here the cardinality of the query. That means if many rows are returned, a high percentage of the data is returned, then the answer is different to a low percentage of the data. And a rule of thumb that is important to know when you do performance tuning is indexes in combination with nested loops, which is one of the join methods of Oracle, is usually the best approach for small result sets. So if you have only small numbers here in the cardinality, this is a good execution plan. And hash joins are good if you want to join big tables, for example, without a restriction, without a where condition, and so on. In this case, as we can see here from the cardinality, the numbers are quite small. So in this case, the option A would be the better solution. This is the typical query that you often have in OLTP systems, that you have big tables, but you only query a small result set of these tables, only a small percentage, and then usually an index is quite useful. But how about this execution plan? Is this a good one or not? Here we have a lot of or only full table scans. We have hash joins, so completely different execution plan to the previous one. When we look at the number of rows here, this is not a mistake. This is really the purpose of this query is to query 500,000 rows from about 15 or 12 or 15 tables. And this execution plan here is part of an extraction job. So we load data into a data mart of a data warehouse and read it from a core data model, in this case a data vault model. That's from another presentation. I extracted this execution plan, and actually, although no index is used here at all, this execution plan is really good. It is the best execution plan for this type of query. And that's important to know when you have the question, is an index scan or a full table scan better? It depends on the selectivity. If the selectivity, that means the percentage of the data returned, is small, or we usually call it a strong selectivity. That means an index scan is a good approach. Index looks like a tree, and then you find the corresponding rows in the tree. You find the row ID, and with the row ID, Oracle can access the corresponding table blocks directly. And the full table scan, that's just a sequential read of all the blocks in the table. And this is useful for a weak selectivity or a high percentage of rows of the table that are returned. In this case, a full table scan is better. Yeah, what means low and what means high, or strong and weak? So there is a percentage where you can decide, okay, when it is less than this, an index is better. When it is more than this, a full table scan is better. And that's one of the questions I usually ask in the performance tuning course. I ask the people, so what do you think, where is this, just as a rule of thumb, where is this border between full table scan and the index scan? And here I have 4 different answers. So an index scan is better if we have less than 80% of the data, 50%, 20%, or 5% of the data. Many people think the typical answer, the first answer that comes from the audience is usually 50%. So that would be answer B, but I don't know whether you already decided, but in this case, D is more or less the selectivity. So if we have less than 5% of the data, sometimes it's 10%, sometimes it's 3%. It also depends on the data types and the size of the table, configuration, and so on. But as a rule of thumb, that's quite impressive. When that means less than 5% of the data, that means if you read, let's say, 10% of the data, it's faster to read the whole table and skip 90% of the rows that are returned before they are displayed in the application. And that this is faster than to read this 10% of the data through the index. That's because there is always an index scan is always an index in combination with the table access, and that makes it slower. There are some other reasons like multi-block read mechanisms and so on. And so it is the number or the percentage of rows is probably smaller than most of the people think when they think about, or when they hear the first time about indexing and full table scans. And this I want to show you live, and for your eyes only means that if you only look at the slides afterwards, you don't see these live demos. But because the session is recorded, I think you also will have, or other people will have the chance to see it later then. Okay. For this live demo, I hope you can read it. For this live demo, I use just one table here, the table employees with these attributes here, and some indexes which I created just for the demo. So we have a primary key, which is a unique key here on the emp ID. We have some additional index on department number, on a flag license to kill, hire date, last name, and a combined index on first name and last name. And now I run several queries, and we always think, or you can think, what would you decide if you would be the optimizer? Is an index scan better, or is a full table scan better? The first example, we just select one row of the table, James Bond. So where last name equals Bond, and of course James Bond is unique. There is only one with employee ID 007, and for this I think it's quite obvious when we have this index on last name, this index should be used. And this is the case here. So-called index range scan is done. Index range scan means it can also return more than one row if the name exists more than once. So this is obvious that the index is the fastest solution. What happens if we have a query with a like operator, so and a wildcard? So we are looking for all employees starting with a name starting with B. And in this case, 444 rows are returned. And from the percentage of the rows, I think the whole table has about 6,000 rows. So that's more than this, more or less 5%. In this case, the full table scan is performed. Almost the same query, but this time we are looking for a name starting with Q. And then we have the Q. When you know the James Bond movies, then you know that Q. And as far as I don't, at least I don't know his first name, but there are some other two people with a name with Q, but only 3 of 6,000, so definitely a small number. In this case, the optimizer decides to do an index range scan. So as you can see, this rule of thumb does not work only on PowerPoint, it also works in the database. Let's see how many employees have a license to kill. Of course, 9 of them, all the OO agents. Some of them we don't know the name, so that's information hiding here, but one of them is James Bond. Only 9 of 6,000 rows, also a candidate for an index range scan. On the other side, if we want to know how many have no license to kill, so that's 99% or more than 90% of the table, so 6,400 rows. In this case, full table scan is the better choice. Okay, it works. Now let's go to Moneypenny. Eve Moneypenny, by the way, I Googled and found that one of her names in the movies is Eve. Because there is only one row here also with like money percent, it works as before with Q. So index range scan is used. But the other way around, if I look for all the names that, here I look for the names that start with money, but now I want to know all the names that end with penny. It's also one row, Moneypenny. But in this case, because the wildcard is at the beginning, even if the selectivity is small, this doesn't work with the index. In this case, a full table scan is performed. And that's something important to know. Index is not only used when it is useful for the optimizer, or a full table scan is used when the selectivity is too high. There are also reasons why when you want to use index, but it is not possible because of the type of the query. So we have to think about how to write this query. Or another tricky example I show here. This seems to be obvious when we look for an employee with the employee ID, which is the primary key. So we are looking for Miss Moneypenny with the EMP ID 123. So I think all of you, and me too, would expect that in this case, index scan, index unique scan in this case would be performed on the primary key index. But when we look at the execution plan, a full table scan occurs. What is the reason for that? The answer we find here, because in this case, we thought that the EMP ID is a number, but in the table, it is defined as a character. And therefore, a two-number function is done automatically, so an implicit time conversion. And that means that the index cannot be used anymore. In this case, what would help is a function-based index, or what we can do is we can rewrite the query as we will just see. The reason for that is EMP ID is defined here as a varchar2 column, because otherwise we could not store the 007, so it would be stored as a 7. That's the reason for for this. But because we didn't know that, it didn't work. But if we write the primary key or the 1, 2, 3 in quotes as a string, then the index would be used. So that's important to know, and that's one example where you see that the data model or the physical design of the database is important for performance. It's not just the index that is useful, it is also the query has to correspond with the data types of the table definition, otherwise it wouldn't work. Okay, last one. Oh, I'm already I'm very behind the time. I have to hurry up a little bit. Yeah, I will skip that. Otherwise, we will not come to the other things. Okay, let's continue with the slides again, and I come to the man with the golden hint. Hints is also something that are often used in databases when the performance is sorry, I'm just checking the time. When the performance is bad, you can add hints to solve the performance issues. And the concept of hints means that we tell the optimizer with some special comments which execution plan should be executed. But actually, if we add a hint, for example, an index hint to tell the optimizer use this index, that's not really the truth. So we don't tell the optimizer to use this index, but what we do, we forbid him to do something else. Or when we think of all possible execution plans, this is a kind of a decision tree for the optimizer. So here we have different execution plans here in this tree. Each of them has individual costs, and what the optimizer usually does, it executes the execution plan with the smallest cost. In this case, this would be here the 47. That means the execution plan join with table T1 and T2. It would start with table T2, would do a nested loop on T1, and for example use an index, a special index here in this case. And if we say, okay, I don't want that you use this execution plan, I want that you use another index here, use index 2 on the table. So we add an index and say, okay, on table T1, index 2 has to be used. That means we cut this branch here. That means this index cannot be used. So we expect that this execution plan would be executed. But what the optimizer does, it does the same as always. It still has the decision tree, now with one branch less than before. But in this decision tree, it decides to use the cheapest execution plan. And the cheapest execution plan here is the 49 here on the very left. So it does a completely different execution plan. It starts with a different table and doesn't care about this index anymore. And that's a typical thing that you probably have seen if you add hints. You add a hint, but then the optimizer does something completely different. Either it just ignores the hint, or it seems to ignore it, or it changes the execution plan in a different way. And to make sure that our execution plan that we want to use is used, we have to also cut another branch. For example, with a leading hint, we can say, okay, you have to start with table T2. And in this case, the whole branch here with all the sub-branches is cutted. And then from the remaining execution plans, the 56 is the cheapest one. And now the right execution plan is executed. That's how it seems to work, but let's see whether this is really the case. And for this, I show a shorter demo now. We have a join between two tables, employees and departments, and we are looking for a bond again. And the optimizer decides to start with departments table and do a merge join, which is one of the 3 join methods in Oracle. But for me, from my experience, I would say, okay, because we have only one bond, it would be more efficient to start with the employees table through the last name index and then do a nested loop on the departments table. So I implement this with a nested loop. So I say, okay, I want that the departments are joined with a nested loop. And the result is not a nested loop. We still have the merge join from before. Why that? Because the optimizer started with the department table. So this nested, so this index here, this hint doesn't work. It is just ignored because when you start with table D for departments, then there is no need to join this table, neither with a nested loop nor anything else. And since Oracle 19c, we have this hint report at the end of the execution plan. When you add some hints that are ignored, there is a comment why it is ignored, and here it is unused because it is not relevant for this execution plan. So, okay, perhaps we have to do it the other way around. So as in this case, I do a nested loop with table E. Let's see whether this works. A completely different execution plan. Now we have a hash join, but I told the optimizer to do a nested loop. Why that? Because I told the optimizer to use a nested loop for the employees table, but then the optimizer said, okay, I can do that, but the costs for this nested loop would be higher than if I change the join order and start with the employees table. But then in this case, I would prefer a hash join. So if we really want to be sure that we have the execution plan that we want to have, we also have to define which is the leading table. So we tell the optimizer to use the employees table as the leading table and then join the departments table with a nested loop. And now finally we have the execution plan that we expected. Okay, that's how hints work, but hints do not work like the so-called golden hint, which is the title of this part here. Many people think that there are some hints available that just can be used to improve performance. For example, here, quite a similar query, except that I join another address table. And to find James Bond here, to find one row from these 3 tables that runs for 11 seconds. That's definitely much too long for this small result set. How can we improve that? We just insert golden hint here and run the query again. And in this case, it's very fast. It runs 0 seconds. If I run it again, it is even faster. By the way, it's 007 here, I just see, but that's just in this case. So I remove the hint again, that you really see that it has to do with the hint. And without the golden hint, the query is, oops, yeah, it is already running. So it will run more than 10 seconds again. Okay, that's not how hints work. They work like this in my database. So the golden hint works here, but it's not a feature of Oracle 19c or something like that. If we have time, I will probably show you at the end what I did here. But now let's go back to the demo I showed you before with the with the two tables I joined. What I did here is the original execution plan started here with a merge join, then with the nested loop. I said, okay, don't do a hash join or a merge join on the departments table. Okay, that's nice when I cut these branches, but when the optimizer decides to use this execution plan, then it still works as before. If I do a nested loop on the other side, then it switches to another execution plan. And if I say, okay, you have to start here with the departments table and use a nested loop, so no hash join and merge join, only this branch here remains, and then this is the perfect execution plan that is executed here. Okay. No, that's not, no. Ah, no, here. Okay, another survey question here, which query is faster? So it's the same query, but the one on the left has no hints, the one on the right has several hints, so these golden gun hints. Which is faster? We don't know, but when we execute it, then we will see the result. Of course, we have the cardinality here. It seems to be better here, or when we look at the costs, so this execution plan is cheaper than the one on the right. That means option A seems to be faster. But when we execute the query, we see the first one was running for 35 seconds and the other one for 1 second. But the costs are here much higher. And this is typical in combination with hints, because when we cut the branches, that means we tell the optimizer not to use his decisions. And the decisions are made on the calculation of the optimizer, so on the calculated of the cardinality, which is perhaps not the right number of rows because of missing statistics or complicated queries, or there can be several reasons for that. And in this case, it is normal. It is the typical case. As soon as you start to add hints, then the costs of the execution plan will increase. But if you add the right hints, then the performance will be better, like in this case. So actually option B here, the second execution plan, is the fast one. Sometimes it happens that you add the wrong hints, and that once happened to an attendee in the training in this workshop, that he added a wrong order of the tables and the wrong join method. And then the costs are also very high, but this execution plan is really bad. And it was so bad that I extracted the execution plan then from another session before I killed it, and it was running for 8 minutes. In this case, it's good to have a license to kill, at least to kill the session at the end. Okay, we are almost at the end of the presentation. So there is no time left, but at least we have no time to lie, but a time for a short summary. So which of the myths about SQL performance tuning are true? I have several questions here, and the answer is always yes or no, or it is correct or it is not correct. Let's just short go through this list, and then you can think what is the right answer, and then I will show it. So performance should be considered after deployment. That's what after development. That's what we saw at the beginning. That's definitely not true. It has to be considered in all phases of a project. And more memory helps to improve performance. Yeah, that's true. But not only. So it can happen that even with a lot of memory, so I saw examples of queries running on an Exadata with many CPUs and a lot of memory, and even they can be slow if you, for example, miss a join condition and do a Cartesian product or things like that. So there can be reasons why even with a lot of memory, this doesn't help. Adding more indexes always improves performance. That's not true. It can improve the performance, but the always is definitely wrong. So too many indexes can even slow down the performance, especially the performance of insert, update, and delete statements. Full table scan is slower than an index scan. No, not really, for a high number of rows. So for a weak selectivity, this is not the case. The next one, I skipped this part in the demo. There is also a reason to use indexes for count star queries, and actually many people think that the count one is faster than a count star, which is not the case. So in both cases, if there is an index available on a not null column, it will be used in both cases. So it doesn't matter whether you count the primary key column of the table or do a count of a constant or a count star. You always have the same execution plan. Hints force the optimizer to use a specific execution plan. That's actually true, but not true in all cases, as we have seen in the second demo. There are cases where this is not always the case, and in this case we have to add some additional hints. What is definitely wrong is that indexes reduce the costs of the execution plan. It's the other way around. So whenever you add hints, the costs of the execution plan will go up. So the number will be higher than without the hints. And then finally, the golden hint always makes query faster. This is definitely not the case. That's only the case in my demo, but usually that's not true. So most of the myths are wrong here, or just partially true, except the last one, that James Bond will always win. And I think even in the new movie that should come out hopefully soon, but I heard some rumors that they skipped it again. But I'm sure that even in the new James Bond movie, he will win at the end. Okay, I'm almost at the end. Before I come to the questions, I think the first question that will be asked will be, what is this golden hint for? But because that could be interesting for everybody, I will just show what I did here, or just show the solution. I run this original query again. It will run for 11 seconds. And when we look at the execution plan, I know with the golden hint, it is running faster. So what happened here, when we look at the execution plan of the original query, we see that the hash join and the nested loop starting with addresses without any restriction is done. So a very bad execution plan. And this bad execution plan is executed before because I created the SQL plan baseline, which is usually a feature to improve performance. So you can combine, so you can tell the optimizer to use a specific execution plan whenever a particular statement is executed. And for this statement, I created a bad plan baseline, and therefore this execution plan is used. And whenever I change the query, so with a comment or with a hint, and in this case, the hint is just the wrong hint, which is ignored, but it is a comment, and therefore it's not the same query again. And then the optimizer decides to use the original or the best execution plan, and in this case, a fast one will be performed. And the golden hint is just ignored because it is a syntax error here, and therefore the only reason for this golden hint is to turn off the bad SQL plan baseline I created before the presentation. Okay, I'm at the end of the presentation. I saw that there were already some questions, and I think we have a few minutes left for answering the questions. As soon as I find the Zoom again. I do it here on my iPad. 7 questions. Okay, let's just go through the list. So the first question, it depends. With partition pruning less than 5% could still be full partition scans or better. Yeah, that's from Toon Koppelas. Yeah, thanks for this comment. I didn't talk about partitioning in this presentation, but you're right. So in a lot of cases, partitioning is even the better option instead of indexes. But not everybody has partitioning available, so it is an option that needs additional licensing. But if you have partitioning in place, that could also help in many cases. Yeah, I just have to, no. Then I really have to do it on my screen. So the next last name like %penny, it's because the last name is not having a uniqueness. No, that's not the case. That's because this query did a full table scan at the end, because when you have a wildcard at the beginning of the constant of a like command, in this case, the index cannot be used unless you do a reverse index. That will be a solution here, but then it doesn't work for the wildcard at the end. Then the next question, yeah, that's when I don't know when it was asked. So the comment is that is having non-unique index. No, that's the same. So sorry, there were 2 questions with the same. So last name like %penny, is it because the last name is not having uniqueness and having a non-unique index? No, that's not the difference. That's still the same question. Then high buffer gets, one tip for solving problems is, yeah, I think that's a bit too detailed to show here from Jefferson. I think I will reply it afterwards after the presentation. It does not make sense that I read it here. Does the golden hint use outline or another plan stabilization technique? Yeah, exactly. That's what, oh, I cannot read this Russian name, but that was, it was not an outline here, stored outline, but a SQL plan baseline, but with a stored outline, it would work as well. And then there is a question which is actually an answer, no, but I don't know the question for it. So yeah, what Babu meant here. And the last question, where can we have your examples from? Yeah, the examples, they go to a special schema that we use for the training, so it's not available online, but at least you will see the live presentation or the live recording of the presentation afterwards. So I think the link will be provided to all the attendees. And by the way, I will tweet that afterwards. There is already another recording of this presentation from the Apex Connect available, which also shows this demo. But if you that's Rumen Ivanov. If you want to have the examples, I can send you the scripts, but without the demo schema, it's probably not very helpful. But if you want to have it, let me know. Okay, thanks. I think we just finished in time, so 10 minutes before the next session starts. So Kim, my colleague from Trivadis, today, by the way, is almost a Trivadis day. So 3 or 4 speakers are from Trivadis, and Tim is the next one. And I hope all of you do the same like me and will join his session.